compare to their hot rolled counterpart. But it's probably also more important, you can actually make them customized. So you can say what size you have, and they have higher precision because those elements here, they come in high precision. And of course, you do not weld it manually. I think now they do this robot kind of thing where you really weld it. Have you guys ever welded? Has anyone here ever used a welder? No one? I actually did only one test and I miserably failed. It's a very, very challenging process. Probably the most challenging, I would think. Right? And for those who want to go into welding, I mean, they get a shitload of money. Right? In my previous job, I had a trainer. I was working in a company that was specialized in welding. So I actually had one time opportunity to use a simulator. Right? So basically, you have to really go and try to weld. The point is actually, if you do it right speed, right direction, and my hand is shaking, right, then you would actually ruin it. And you know, if you see those people, they're making these big boilers, right, those big vessels, right, the pressure vessels. This is an enormous responsibility because this has to be leak-free, right? There's no leak or something like that in there. And as soon as you make a little mistake, right, a little sway in your pathway, then the whole thing is actually ruined. So welding is a process. I think you did speak about that with Matthew briefly, right? I'm pretty sure you did. It is simply you have one plate here, say another one here. Now you actually heat it up and then you put here material, fillet, they call it fillet, right? For instance, the fillet weld. And because of the thermal process here, they will actually fuse together. With other words, you add additional material and this becomes fused. And fused means separately, right? They cannot separate them anymore, except of cutting it. Right? So welding is really a very laborious, very challenging process, but the rewards you get is higher performances, right? And of course, you do this with machines. I wouldn't do this anymore. But if you want to earn a shitload of money, become a boiler maker. They get $500,000, I think, the good ones. But the point is actually this is a laborious job, and I think you won't make it for 30 years. I think you're going to die before it. Because of the fume, right? There's a lot of challenging environment. But those people in the mines or so, they're amazing amount of money. Right? But not everybody can do this. It is simply, it's physically demanding, right? But I think there's a shortage in right? Or welders in particular, right? All right, I mean, that's all I want to say about, so we have two different, but that's the only difference, welded beam, universal beam. Right? Universal column, welded columns. Okay, so these two we have to consider, and that makes a difference here for you guys as well. Right? So please notice the difference. Physical properties of steel. You know some of those. We talked about, at least about the elasticity module, right? ES steel. Remember we used that, for instance, for the rebars, for the tensile strength and how to calculate the stress. And it was 200,000, right? So there's no changes here. There's another one which is called the shear modulus. You need that too when we do calculations. That's why I bring it up here, because all these things are needed. Oh no, actually only those two, the rest is... so these two definitely, but I will come back to this point. Poisson's ratio. Anyone remember what Poisson's ratio is? Probably not, right? And the density. So that means 1 ton of steel, or 1 cubic meter of steel, that's what it reads, weighs around about 8,000 kilograms, 8 tons. So again, we need this, and to some extent this. Okay. So now this is probably a bit difficult to explain, because I had this issue all the time with explaining what's the difference between steel grade and steel stress. So I tried to come up with this one here. Again, I will upload this PowerPoint as soon as I finish this one. The mechanical property of structural steel are given in this table for the Australia Steel Designer, right? Page 23. So that's what you will see here. So you see the product, that's the one which you also use. And that's the one which you, for instance, see in the One Steel catalog, right? And they have here what is called a steel grade. They come in all different kind of things. Something like this one here, grade 300, 300 LO, and so on. Right? Remember when we had our rebar? Our rebar was, for instance, N32, right? And it was made of a steel D500, right? This was another way to describe a grade, right? That means that steel rebar has this class D or grade D500, and that corresponded to 500 megapascal tensile stress, right? So that was here 500 MPa, right? Because this one was the diameter, right? So now, there's a something different meaning here. So when you see, for instance, a steel grade of 300, right? When you look at this, it doesn't actually mean now that this 300 is the yield strength. For instance, that steel grade 300 says, for instance, the yield stress is, for instance, for that particular one is 300, but for some others it is not. And the tensile strength is completely different. Right? So that 300 still partially corresponds to the yield strength. That's the same as here, because that's the yield strength. But yield strength means when it becomes too much to tense. But you can see here the tensile strength is now different. So you have to be very careful with the interpretation. Steel grade doesn't automatically mean it is the tensile strength, for instance. So I just wanted to bring it up here. That's when the actual yield stress of steel grades varies from the nominal ones, right? That's basically this one here. That's the nominal. We say steel grade 300. That means the yield stress would be around about 300. But it can vary. And that's what you see, for instance, here. Because when you look, for instance, at the different thicknesses, then you can see it can vary. So which means you must be careful, you must read the tables to find the right strength, yield stress. Right? But again, for us, we will see, right? We'll see when you look at the steel catalog, it will mostly be the same. But again, you must read the tables carefully. And I've also highlighted down here the fact that, for instance, then you see here the grade, steel grade 300, a steel grade LO, and so on. There's 400 here, and there are more. When you look into the catalog, there are much more. Right? And down here is actually also called 300 plus. Right? 300 plus is the one which you will also see in your One Steel catalog. You use that in stage 4 already, and you're going to use that in stage 7 again, excessively. So I want to highlight that fact. 300 plus is another steel grade which is kind of, I do not know, it's probably the standard. I'm actually surprised. Right? But here it says about that 300 plus range of that section, one steel, here, that's the name already, complies with the back strength requirement for N depth grade 300. Right? So in other words, the 300 plus is the same as 300. Just simply, steel grade is some sort of an identifier, a label. Right? It generally corresponds, that number, to the yield strength, but definitely not to the tensile strength, which means you have to check the catalog for the right numbers. And you will see they are different. This one is relevant for your project. When you talk about, basically when you have wrapped up your design and basically come up with the technical drawing, and then you have to hand over your solution to the clients, right? There you have to basically discuss briefly methods of corrosion protection, prevention of corrosion, right? So you will then, when I say, you have to simply write a few sentences about what do you think about the best way is to make it corrosive safe. Right? So, and here this is actually the PowerPoint presentation which I created, where I basically rummaged around the internet to find some strategies. So you actually, that steel is normally like this, right? That's actually when it comes. You see, it's rusty, it's dirty, it's corroded, right? Simply because the surface actually is interacting with the environment, moisture. And that's rust. Right? If you just go over that. So, in order to basically make that nicer, especially when it is exposed to the environment. If that would be within the concrete, then I couldn't give a shit how it looks like, right? The only thing what you make sure that it doesn't corrode further. But when it comes to beautification, that doesn't look nice, right? So which means you want to appeal to the beautification of this one. So you coat it, for instance, right? So you can actually use, for instance, this one. You basically prime, you paint it. This one is a paint which basically also serves as rust protection. When you go to Bunnings, when you paint stuff, right, for steel, there you basically have, it's the same thing, right? So you basically grade those layers, and then it is A, much more appealing, and B, protected against corrosion. That is the cheapest solution, of course, but as you can imagine, you have to repeat the coating every few years. They have to come on and paint over it. You've probably seen those guys on the Golden Gate Bridge in San Francisco. You know why it's red, right? It's because it's coated. And every year, I think every year, they have to climb up these ones and paint the whole stuff. Every year. Simply because of because San Francisco is on the bay, it is actually exposed to fog, moist air, and salt. Which means the paint they have actually doesn't last longer than, I do not know what intervals they have, right? I saw a documentary, they really have to paint it in a particular interval anew. Which means it's a lot of manpower, right? To actually get it painted. Because when was the Golden Bridge built? I do not know. In the 30s, 40s? Not sure. Back then they used simply steel cable and steel, and they didn't have any galvanized things, right? As far as I remember. So, so they couldn't replace it or don't replace it. So they have to paint it. And I think with all kind of suspension bridges, you have the same issue where you have to paint it just to protect it. Right? And the last one is here, galvanized. This can only be done when you actually make these things, when you manufacture those steels, because that requires chemistry and also electricity, because that's actually then using an electrochemical process. But of course, once you have done that, that's actually this coating, right? Once it's done, that lasted for, I do not know, not eternity, but at least for many, many years. Because what you have, you simply have the zinc, and zinc is in particular the one which is corrosive prevention, that actually simply deposits on the surface, on every single area, and gives a coating on it, which is, I don't know how deep it is, and it sticks there. Right? It's a really like penetrating into the skin. You can also spray this one, but that's a different story. So this is here for you. When you have to discuss your final handover, this is one of the ideas which you probably can check, and then Google a little bit how much it costs. It's not that expensive, and then should be doing it. That's why I bring it up here, for no other reason. So this one we do not have to discuss anymore. We talked about this capacity reduction factor, the phi. For steel, we will get another one. Concrete column, what was, anyone? Concrete beam, what was the reduction factor? You submitted yesterday? What's 0.8. What was it for the column? Or what did,
0.6.
0.6, yep. What was it for the foundation? 0.7. And now for steel, it is going to be 0.9. 0.9. And it's going to be 0.9 for the beam and the column. That makes our job even more easy, because you have to remember only this. So 0.6, 7, 8, 9. Easy to remember, right? So that is actually why I put it up here, because that's the one which we are going to use next week when I introduce to you the steel beam design and the column design. Load factor, again, so we talked about this already, we're going to use this again, pretty much exactly the same thing as we did with the concrete beam and the concrete column. And with that, that was all I want to say in quick run about steel. I will recap next week when we talk about this in my PowerPoint presentation. I will actually recap some of the information. But steel grade. This steel grade is a very critical issue. I know that people actually make a mistake there, and next week I will introduce it again, just to make sure that this is very clear between the steel grade and the actual strength. That is this. Since everybody's mind is at the moment at the column, right? Yeah, no, that's okay. That's fine. I can live with that. Right? The point is actually, it was open for 2 weeks. Right? At least the theoretical stuff should have been done previously. The only thing what you need to do today, supposed to do, is actually the space gas. Right? Because that's the only thing which is missing in your for your submission, right? So since I showed it last week, but I'm pretty sure half the people were not there. So I mean, they were here in spirit only, but not listening. So I just want to quickly go through it. Not go through it the entire thing. I will only show you 2 things which are important for the column, right? So and I do this right now, so that then after this, then I'm finished with my part, and then you continue with your stuff. Huh? So, let me quickly start up space gas. So tomorrow I will mark definitely crack 3. I will actually probably start today, because I can do this now, because I'm more or less, because now it's your thing. So I will mark as much as I can, so that you have hopefully most of the results by tomorrow. But I cannot guarantee it, right? but I try to do my best, right? And for those, because I think that question came up by someone, and when I mark, remember, when I mark, then I give you a new deadline. As simple as that. And it's usually, for the first submission, it's normally 5 days, and for the last one, it's only 2 days. Right? Because normally, when you have to, well, we are supposed to wrap up the bugs as quickly as possible, right? So that means we do not want to drag this on forever. So that's where it came up basically, and it's also in the instruction, it's also in the assessment policy that for the first one, for the second, is 5 days, and for the last one, it is only 2 days. Right? Or the second, and for the last one, when there's any required for this one, 1 day. Right? Because most of the, if it's basically only a minor thing, it's like 95%, that can be done quickly, right? And then that should be submitted as quickly as possible, right? So, but of course, only after I mark it. I set the deadline. From my point of view, when I mark it, then of course you have those full days, right? So, if, say for instance, I would not start until next Wednesday, for instance, then of course, when I mark it, then you have 5 more days. Oh wait, let's go quickly to this one. Okay. Oops, what's happening here? All right, I have already opened up here a column, which I do not want to explain because you know how to set up the material, cross-section and all this kind of thing, because everyone has a different one. So I simply want to show only 2, 3 things. Last week we talked about what kind of supports do we need for a column. Right? I showed that on this example. Right? So what support did we need and where? We had only a fixed support on the bottom. Nothing else. There's no support on top. It's simply free. And remember, when you draw, and I think I mentioned it again, when you draw a member in space gas, it is represented by a line with 2 nodes on each end. Right? By default, when you draw it, they are completely free. So that means you need to restrain those, right? We had the hinge and the roller support for the beam, and now for the column, we're going to use the fixed support. And it makes sense because you want to make sure that when we bend this one, that it doesn't topple over, right? If you have a hinge support and you apply a moment like this, then it will simply like open the door. And remember, a column never moves. So we restrain it. And it's going to be done here by a fixed support. The second one was the load. You remember how to do that?
On the top.
On the top. Okay, how? Okay, so click on this one. Okay, here. How do you define the load? Open up space gas.
Loads.
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 And?
Member distributed force.
Nope.
Loads.
Concentrated.
Oh yes.
You have only what you actually reapply the load on top, right? And on top is only one thing, and it's the node. So that means if you click the node, then of course we apply the node loads. Right? Exactly, the node loads, right? Right? And node loads, right? Oops. Node loads, and node loads. And that's, so you have a load case, there's only one, right? One, remember? And okay, it's pretty much the same as with this one, but now look at the text here. So at the moment, it expects you a force in x, y, c, and simultaneously an x moment, y moment, and a c moment. Okay? So last week I showed an example. I showed an example for this one here. I showed a rectangular example, but make it here easier. So let's say, and that's now important to realize when you look at the, let me just move this a little bit further apart here. There's down here your view cube, and it tells us our coordinates, right? X, Y. If you open up Space Gas, you should see the same thing. So at the moment we have, so this is X, this is Y. Now here is my node. So now I want to apply the load first. That's easy. So what load do we have? We have a node load, say, depending on, and in which direction does it go? So we have, so what load would you choose? An X load, a Y load, or a C load?
Y.
It's a Y load, of course. And of course it is negative, because it goes down. Axial load goes down. So we write down here, okay, this will be here, minus whatever the load was, say 1000 kilonewton, right? And that is actually a Y load. Okay? Because it goes down. Okay, then give me 1 sec, because I just want to grab something.
Con el que envié, que son 5 días y